Good evening, everybody, and thank you all for joining us this evening. My name is Dr. Billy Teets, and I'm the astronomer and the acting director for the Vanderbilt University Dyer Observatory. We're going to have a great time tonight. We've got a terrific speaker. I'm really excited to have her here. I've worked with her over the years, and she's just an awesome person in every way that you can imagine. So we're delighted to have her here. So before we get into that, though, I wanted to give you a little update. Unfortunately, Dyer Observatory has not yet been able to open back up to the public, but thankfully we've still been able to do a lot of our outreach in the virtual means like we're doing tonight. So tonight is actually the first of our virtual Meet the Astronomer lecture series. And so if you've been to the observatory before, you know that we do a lot of different public events, including our monthly Meet the Astronomer series. So we haven't been able to do any of those in person this year, but we've now been able to start our virtual series. So we're very, very excited about that. Another event that we've got coming up actually this Saturday is another virtual event. It's our September virtual star party. So Dyer Observatory, along with the Barnard Seaford Astronomical Society, the Memphis Astronomical Society, McGill University, and Bays Mountain Park and Planetarium, we're all going to be teaming up again, and it looks like we'll actually be able to do some viewing. It looks like the clouds are going to clear out for us, but even if we do have some clouds, we're still going to have a great time. We'll do a lot of Q&A, and so if you can make it, we really encourage you to be there. It is this Saturday from 7:30 to 9:30, and that is Central Time. Check out our front page of our website for updates and also links to our virtual events. So now, on to tonight's talk. So our speaker for this evening is Dr. Erika Grundstrom. So Dr. Grundstrom loves sharing the wonder of the universe with everyone young and old. She's a senior lecturer and also the director of astronomy labs and outreach in the Department of Physics and Astronomy at Vanderbilt University. So her research combines interests in massive stars, spectroscopy, and also astronomy education. And I can tell you right now that she is an awesome educator, so you all are in for a real treat tonight. She received her PhD from Georgia State University in 2007, and her education and outreach have brought her into many of the schools around the area. In fact, some of our viewers tonight may have seen her with the big inflatable planetarium that's always a hit. She's been able to work with all grade levels and do a lot of education and astronomy outreach. So without further ado, I'm going to turn it over to Dr. Grundstrom, and she's going to talk to us tonight about some citizen science.
Thank you very much, Billy. And I'm really excited to talk to everyone tonight. And so I hope that you are making sure that you have access to the chat in YouTube Live so that you can ask questions there. And as Billy said, or Dr. Teets, I suppose, said I do a lot of outreach in the area of Nashville. And so the big giant inflatable planetarium is one of the ways that I've seen a lot of people in the school systems all over here. And I also do teach for the programs for talented youth here at Vanderbilt. And so if you are a part of that or have been a part of that, then I'm the astronomer that generally does stuff there. So I'm really excited to talk to you today about citizen science. And so citizen science is one of these things that we get to, that anybody can participate in. So I want to just give you a quick overview of what citizen science is, also give you a few options, well, several options, really, I should say, for participating. And it's not just astronomical. A lot of them are astronomical, but a bunch of them are really nature-based and environmental-based. So without further ado, let's do that. And let's get going. So one of the things about citizen science is that it has been known by a lot of different terms over the years. And these are some of the main terms that have been used. And so you can kind of see one of the things I like about this is that it's showing you what sort of things people have decided to talk about, like participatory monitoring or volunteer monitoring. So it's kind of organization of volunteers. And one of the things about citizen science is that it is not paid. And in general, you're not paid to do this work, but that's why you're volunteers and why it's crowdsourced or community. I mean, maybe you might get paid for something, but in general, it's not. One of the other things about citizen science is it's not a science project. Those things, science projects or STEM projects or STEAM projects, are designed to teach a person about how to do science and, and actually like follow through with a whole bunch of different pieces. That's not what citizen science is about. Also, citizen science is not participating in a poll. So if you got called up and asked about your opinions on certain things, or asked about something about your health, that's not necessarily citizen science. For the most part, it's not, because you're the one being asked about it. If you are actually gathering some data and contributing it, then that's usually what's called citizen science. So with those kinds of things in mind, I really like to do some interaction and like to see a little bit of what people are doing. So what I'd like you to do is I would like you to, on your phone, like let's say maybe this on a phone, maybe it's a new tab or something like that. Maybe on your laptop or something, you go to menti.com, and then you're going to put in this numerical code, this 7-digit code. And in that with that 7-digit code, you should end up getting like a little heart symbol to first start this off. You're going to eventually be able to see the whole presentation in this at menti.com. But one of the things about menti.com is I get to ask you questions and you get to participate in things. So get that kind of going, and we're going to start our first poll. So given the different instructions that you've had, or about what citizen science is, have you participated in it yet? And maybe you're not exactly sure if you have or not, but you can still try. That's one of the choices. So you see like a bunch of little dots showing up over there and gathering up in different places. So remember that citizen science could be other terms that maybe you've run into, amateur science, volunteer monitoring, participatory monitoring. So you should be able to also see some of these words on your, if you do this on a phone. So yeah, I am, really interested in what people are, have done in the past. I'm gonna leave a couple more, have this be up for a couple more minutes. And so remember, you can do this on a phone or on a tablet or in a new tab in your, while you're watching YouTube Live. So now I think we've seen that we got about, we have about a third of people are doing, have done something like this. So the thing is, citizen science is kind of an old practice, but it's a new term. And it's kind of come under this umbrella of citizen science. And what it used to be was it's people who were self-funded. So most of the time it was rich guys who were able to do this kind of thing. One of the most famous is Benjamin Franklin, to people, especially in the United States. But in astronomy, a couple of astronomy people are William and Caroline Herschel. They were brother and sister. And William Herschel was one of the first people to or he was the first person to publish that he found a new planet, and that planet was Uranus. So his sister helped him out during the observing sessions, and she also did a bunch of observing herself. So that's one of the more famous astronomical ones. Another really famous astronomical one was Tycho Brahe, or Tycho Brahe. He's kind of infamous in the astronomical circles because he was very eccentric, and he was also very, very rich. So he built his own little observatory, and he had really, really, really sharp vision. So he was probably the best unaided eye observer of all time. And so he would look at the positions of planets and stars relative to each other and then write them down. And so he had a contraption and stuff. He also, as I said, was a little eccentric. He got into a big fight at university about mathematics, and it was a sword fight, and he got half of his nose cut off, and then for the rest of his life had a silver nose, partially silver nose, and he would take the nose out during various dinners and stuff that he had. He was a bit wild, but yeah. So anyways, we also have people like Mary Somerville. She was a polymath in Scotland. And so that means that she did a whole bunch of different mathematical things. And so she did a lot of physics and some astronomical calculations. So, there's all sorts of different people that you could think of. Like Newton was one of these, Darwin. Maybe they weren't exactly self-funded, but funded by others. So let's do another little poll here. So enter in the name of one or two self-funded scientists that's a favorite of yours. I gave you a bunch, but there's a whole bunch of others that you could come up with. So let's start putting those in, and then as soon as you hit submit, then they'll start showing up as a word cloud on this. Oh, Ben Franklin, yeah. So, yeah. Tesla, yeah, that too. Sadly, mostly self-funded. It's interesting to see who people decide. Oh man, people are really going for Tesla now. The bigger with the word cloud, the bigger the word, the more people have chosen that. So that's one of these kind of cool things here. So I know there were at least 25 doing the last one. So I'd like to see if there's a few more. Yeah, so awesome. This is, so we've got some, a few different people who have done a bunch of things. Some people are actually funded by universities, and that's one of the things that is we can think about, is that back kind of before the 1900s, a lot of people were self-funded. And then once the kind of around the 1900s kind of rolled around, then you started getting these universities that started funding, providing jobs for people and then funding them. And that's actually, like, Einstein was actually one of those people. He actually was a university person and was pretty much funded, especially after his whole patent office thing. He ended up getting jobs at universities. So he was kind of self-funded right away. And well, because his job at the patent office did that. So yeah, awesome. This is looking good here. So let's start thinking also about, now let's start thinking more about some things that you can be doing. And in citizen science, a couple of researchers have come up with kind of a level of involvement. And the thing here is that you can be super duper involved, extreme citizen science, where you're actually working with professional scientists to come up with the problems, come up with the way that you collect the data, and the way that you actually analyze it, doing analysis of the data. Or you can be a person who actually collects the data, and that's what the kind of the citizen acts as the censor. And so you're the one who's kind of collecting it and submitting it. So there's kind of all these different levels. And so I'm kind of curious as to what people who have done this, who have done some citizen science, what sort of involvement you've had. And then also then the next one will be kind of what you hope you could do in the future. So our next thing is highest level of citizen science that you've done. And so, by the way, you should have some definitions there. So if you're the basic interpreter, that means that you're looking at a picture and then you make a determination with that. That's something that's done a lot at Zooniverse, if you've ever worked with Zooniverse. So, and if you don't have any experience yet, hey, that's awesome. So I'm just kind of curious on this so far. So we've gotten, so mostly it's no experience, and that's awesome, because hopefully you can get, I'm gonna whet your appetite to start getting out there. Awesome. All right. And so let's imagine that you started doing some of this science. What do you think would be like the most awesome thing for you to start doing? And remember, extreme citizen science is actually generating the question and doing the data analysis, figuring out how to collect the data. That's what extreme citizen science is. That's the one definition that I don't have with you. And it's totally cool to do any of these things. So the basic difference between participatory and extreme is where you're actually analyzing the data, by the way. So, and then, trying to make it basically ready for dissemination or publication. And publication could mean in a journal article, peer-reviewed journal articles. It could be publication on a website. It could be publication to a government entity. It could be published in a lot of different ways. Awesome. So let's start getting into some of the different things that you could be doing. First off, I want to talk about the American Association of Variable Star Observers. So this is an organization that has been around since 1911, and I should say early 1900s. And there are different levels of being involved with with the AAVSO. So you can look at the brightness of stars using just your eye without any sort of aid, just look at the brightness of stars compared to other stars. Or you could use a set of binoculars, and you can try and do some analysis. Or you could use a telescope and do analysis. And so you are gathering the data. You are the sensor that way. You could do this with just your eye without using any sort of anything, or you could use a digital camera. And so take the pictures and then do measurements of those things, of the brightness of stars compared to other stars. And you can also, if you don't want to actually go out there and look at the sky yourself, or if that's not, you know, maybe you can't do that tonight because it's cloudy or something like that, then you could do some data mining amongst all of the data that the AAVSO contributors have gotten so far. Now, there are millions of data points in the AAVSO database. So you could go and look at these things. And so over on, in the middle here, I have a finder chart, you could call it. And so you're looking at a particular variable star here, and then you have different comparison stars to look at. And you want to compare the variable star to the brightness of other stars that are around it. And they're specifically chosen. And then you can get something like the, this is a light curve. So the horizontal axis is date. So this is, you know, how long it's taken, how long the data have been taken for. And then the vertical axis is magnitude, and magnitude is a brightness scale. So the higher it is on this graph, that's brighter. The lower it is, the dimmer. And you may notice that it's pretty wide. Like the data here are pretty wide. The red line shows the average brightness from all the different observations on those particular days. And these are, you can kind of see them that they're in these bars. That's because that's a fraction. The only way that you kind of get in between the bars or in between the horizontal lines is if you have a digital image of it to try and get a more precise brightness. But most of the time you go to 1/10 of a magnitude. And so, yeah, that's why they look like that. It's just a thing of the data. But you can totally do this. Everybody can do this. And they have several different helper documents, and you also can subscribe to have a mentor to help you out with this. So if you're interested in looking at stars and looking at some data and contributing data to actual astrophysicists, then this is a great way of doing that. And they also have things like, there's been various like explosions or kind of brightness differences in certain stars, and they will put out a bulletin saying, oh my gosh, we need observers to go look at this thing that is suddenly really bright. You may have heard a couple of months ago about Betelgeuse or Betelgeuse getting dimmer. And it was people from AAVSO who had a lot of the early data that really were showing that star was getting dimmer. And it seems like there was a dust cloud that was kind of obscuring some of the brightness of the star. Now we know that after having big fancy telescopes pointed at it. So yeah, so you could be one of those people who is observing for this kind of thing. I will say in my own dissertation, PhD dissertation, that I used AAVSO data to look at historical brightnesses of a couple of the different stars that I looked at in my dissertation. So so people use this, and if you want to see kind of like how long this has been going for, here's the light curve, the brightness variations of a recurrent nova called R Ophiuchi. And Ophiuchus is a constellation that you can see. It kind of, Ophiuchus is the snake charmer. He has snakes in his hands as far as the constellation goes. But what this is this is a binary star system. It's got 2 stars in it, and one of the stars is a white dwarf. So it's already gone through its death throes. It's the naked core of a star. And then it has a companion that is donating mass onto this white dwarf. And and that mass will build up and build up and build up. And then all of a sudden it will explode in a thermonuclear conflagration. And it's just the outer layers of the star, and then stuff starts building up again. And so you can see, like, here's one of those spikes here, and then there's a couple more. And So it happens every now and again. And so this is one of those ones that you would get something like a bulletin about this saying, oh my gosh, we need people to observe. It's going. So it seems to kind of go on a bit of a pattern, but it's not super precise. So that's why it's really exciting to do this kind of work. And some things have had data for almost a century, but not everything does. So yeah, it's something that's awesome to look at. But you see that it's kind of sparse in the early years, and then now more recently it's gotten a lot more. So yeah. Then another one that you can contribute data to is the globe at night. And it's a light pollution mapping thing. So you can look at what we're trying to do, astronomers are trying to do, is trying to see how bright things are in different parts of the world. And what you would do is you would, once it's part of the campaign, the next campaign is in October, starting October 8th. And you'd either look at Pegasus or Cygnus. And these are things that will be kind of over your head at about 8 or 9 o'clock at night. And then you would match the nighttime sky, like how many stars you see, to various magnitude charts. And and then you would submit the data. So one of the things that I kind of like about the logo for Globe at Night over here is it's showing brighter dots for areas that are especially bright. Like this is where cities are, right? Like New York City kind of area, Los Angeles, and then in South Africa, here's like the big cities in Johannesburg and stuff. So, and then Europe is pretty bright up here. So it's showing you all these different things, but we're monitoring light pollution, and with the data that is collected, one of the things that this is the web reporting form that you can do with it. You get to choose your constellation, you choose your location, and then you talk about the sky conditions. Is it kind of cloudy? Is it mostly, is it really clear? So those kinds of things. And so you can submit that, and it's pretty streamlined. It goes pretty fast. It works. It actually shows up quite well on a phone. If you want to do it on a phone, and then it also, if you're going to do this on a phone and you want to have your eyes dark adapted, it has a red nighttime version, and that's what's kind of shown in the lower left here. So it's a pretty exciting, well-run thing, and they have about once a month they have a new round of constellations that you're supposed to look at, and it works for Northern Hemisphere and Southern Hemisphere. There are some Southern Hemisphere constellations as well. So this one's a pretty easy one to get involved with. And also, if you don't want to actually submit the data, you can download the data. And you can do your own mapping with it and kind of map like how bright has Nashville been in the last, 10 years or something like that. So it's something, that's one of the other things that I kind of like about some of these things, is you can also download the data yourself. So another thing that you can use some equipment for is CocoRoS. This is a meteorological one, and you can submit data on rain, hail, and snow to a network. Pretty much every area that has a National Weather Service station now has a CocoRoS group. So the Middle Tennessee CocoRoS group is, of course, always looking for more people to submit data. And what you would do is you would, every morning at about 7 o'clock in the morning, you would go read your rain gauge. And you can buy special rain gauges they're cheap, okay? So, or they're reasonably priced. But you can buy special rain gauges, and you can do your data submission using the same type of equipment. And if everybody does it at the same time, then you're doing a really good experiment here. And one of the reasons why this was kind of designed is it started in Colorado. That's what the first was. Instead of community, it was Colorado, because the National Weather Service site in in it was like Colorado Springs or something like that. They had only like a little bit of rain, but in one of the, in a nearby area, they got several inches, and it actually washed out several bridges, and some flash flooding killed people. But it did, the official data didn't show that there was that much rain. So that was the way it started, and it's spread all throughout the nation now. So this is a cool way that you can be involved as well. And then if you're interested in radiation, this one is one that's interesting. It's called SafeCast. It's doing radiation monitoring, and now also does air quality monitoring in various areas. It has you can buy the little sensor, and you can take it around with you. There's people who take it around with them to, their vacations and stuff. Well, not that we can do many vacations right now, but still. When we can, then you can take it to different places. Maybe you can go travel around, see if the air quality or the radiation level is different in different areas around your home or around your city. A lot of people in Japan use this, especially around Fukushima Daiichi nuclear plant. So yeah, and you can also download the data from this website as well, so that you can, anybody can look. And they have some good data analysis tools with this. Now, these are all things that these four are ones that you kind of like need equipment, or you could get equipment for. But you can also do things that are kind of apps. So the most popular apps, there's this one called iNaturalist. It's you can totally download this app for free, and then eBird is like the bird watching app done by the Cornell Lab of Ornithology, and you get to submit your birds, and it's really great for bird watchers because it keeps a record of which birds you've seen, and then you can also submit pictures of birds as well. And then iNaturalist, it's not just birds, even though it's got a bird on the logo. It's also it's various flora and fauna. So it's a pretty interesting way to kind of see what's going on in the world and submit data to people who might need it. And then there's the Zooniverse, and the Zooniverse is actually a conglomeration site. So conglomeration sites, these are groups of a whole bunch of different citizen science projects. They're all kind of grouped on one website or one app, and it's a way for you to kind of go to one central place. Everything is kind of vetted, and it has a certain way that you're supposed to that they're supposed to upload data and things like that. So Zooniverse has about 100 different citizen science projects that you can do. Anecdata has 200. SciStarter is one of the biggest ones. It has a lot of the Zooniverse projects within it as well, and that's got 3,000 projects. Citizenscience.gov is kind of interesting. Not everything in citizenscience.gov is on SciStarter, but most of them are. But there things like places like the EPA, they have different things that they want citizen data for. And so that's especially for waterways, for around oil fields, for air quality stuff. That like a lot of citizenscience.gov projects are involved with environmental projects. So looking at that can be kind of really interesting. And before I show you one of the really awesome websites, before I show you Zooniverse, I want to just address something that a lot of people ask about citizen science projects. And that is, what if I get it wrong? Because the thing is with citizen science projects, you're just submitting data. You don't know if it's, like right or wrong. I'm going to show you one of these distributed volunteering websites, and you're choosing something, or distributed intelligence, sorry. You're choosing something and you don't know if it's correct or not. Well, that's science. We don't know yet sometimes for a lot of these things. And so what you should realize is that you're not the only person who looks at, if you're supposed to look at some images, you're not the only person who's looking at it. If you are, if you happen to mistype some data into the entries, you can, you're hopefully one of many people, so that you can, maybe your wildly weird number might get kind of evened out by everybody else. The other thing is that a lot of times there can be AI analysis of data, and they can analyze if somebody's data, some username's data happens to often be really wildly out of like sync with other people's, and you might get flagged. So maybe a higher weight would be given to those who have more accuracy. But hey, people can change their accuracy too. Usually when I start out with one of these projects, I'm not that great at it, or I need to get some practice. And so that's one of the things that also happens with science. You need practice. You need to try and get better and better. So I want us to look at, I don't know if you want to look at it or not, but I'm going to show you one of my favorite websites, which is the Zooniverse. The Zooniverse is something that started it started with something called Galaxy Zoo. And so Galaxy Zoo was something that there's so much data, and computers weren't that great at determining really little fine details, but humans were great at it. It was really easy for humans to figure out if it was a spiral galaxy or an elliptical galaxy, if the spiral thing was spinning clockwise or counterclockwise. So yeah, that's one of the things. It started with that, and then it's grown to this thing that's 100 different projects. So I went to zooniverse.org, and I clicked on projects, and now I'm going to go into active projects, and I'm going to scroll down here, and it's got all these different disciplines. And so climate is a big one. Biology is also a big one. There's a lot of nature projects on this. You can scroll down, you can see like all these different things that you can look at. Climate history of Australia. I'm gonna choose an astronomical one because we're doing this at an observatory. So I'm going to space, and then there's all sorts of different ones, but I'm going to show you a little bit with Galaxy Zoo. And I have, done a lot of classifications of Galaxy Zoo. I actually also use Galaxy Zoo in my astronomy labs at Vanderbilt University. I have students do these. And so if I go to classify, I can decide about, I'm given an image, and then so I get to decide, does it seem to have, is it smooth or does it have some features? Knowing what I know, I can say that it looks like it has some features. And then I can click next, and then it asks me about some of those features. I could also come over here and I get a field guide, and it shows me a whole bunch of different things. And I can try to, I can try and look at all these different images. So that's one of the good things about things at Zooniverse. They all have something that has a field guide with them. So I think that it's pretty interesting. And so you can kind of keep going. I can't see that there's a bar in there. There's a little bit of a spiral ladder pattern. It looks kind of tight. And here's the thing. I don't know, and if it seems like it's kind of reasonable, then hey, that's great. So I'm going to choose a bunch of these different things. Small, next, none. Rare features, nothing unusual. And then I can hit done and talk. And so I can talk about this image with other people. I can leave a note. And so some of these things are pretty, pretty active. And so one of the ones that is an especially active one is Planet Hunters. Oh, that one's pretty much dead. Okay, so there's a bunch of different ones that are really active and some that aren't. So there's a lot of these nature ones where you can people have these photo traps, as they're called. So they take pictures of things and they want to try and classify how many like antelope are in an area, or come by that get photographed, or how many mice, how many squirrels, that kind of stuff. So you can do all sorts of these things, and most of these are done well on a phone or tablet. So I can totally recommend those things there. So let's look back at my thing. So we did that. Other things that you could do, you could go on vacation and help science. There's a virtual reef diver is collecting pictures that people have taken when they go scuba diving or snorkeling over coral reefs. So you could try doing that, or if you have ever adventured to a glacier, you can submit your pictures to Ice King, and you can then help glaciologists figure out things about certain glaciers. So so it's really kind of an amazing thing to do, and then also looking at different street signs in different areas and seeing if they change, and how different language moves throughout the world. So that can be another thing that you could do. If you're interested in trying to figure out a location-based thing, SciStarter also is really interesting in that you can find things via location. Maybe you want to do stuff that has to do with ocean, streams, rivers, or lakes. There's like lots of different things that you could do, different age groups, or projects that are only accessible via the web. So some of these are ones where you go out and do stuff and go find things, or some are like, okay, we're going to give you the images and you start doing some analysis of them. So it's pretty, there's a lot of variety in what you can do with citizen science projects. And then you can also totally start a project of your own. Let's say you've noticed that the stream that goes near your backyard may have some like junk in it sometimes, or you're kind of worried about the water quality. Maybe you would start up a citizen science project and start doing water quality data analysis of it, and trying to get volunteers involved with your project. So I mean, you can go big with this. SciStarter has a really, SciStarter, citsci.org, publiclab.org, and citizenscience.org all kind of have helper things to help you get started with your own project. I would say that SciStarter and Public Lab have kind of the most robust versions of these things. By the way, Public Lab was started right after the big oil platform blowing up in the Gulf Coast. They started right after that, and so they were really emphasized kind of going along the shoreline and seeing what sort of damage there was. So kind of some of these are like a little more focused to some things and some to others. So you can get involved, like really involved. I mean, you can get into this extreme involvement. And so if you started your own project, that would be extreme involvement most of the time. So so yeah. I do want to make sure I mention what kind of could be considered a subfield of citizen science, and that is distributed computing. People who are, maybe a little older may have heard of SETI at Home, which has paused itself, by the way, if you've ever heard about this. So SETI, by the way, is a search for extraterrestrial intelligence. And they need to analyze the data that they've gotten. So they had to just stop for a while and just, analyze and then see what they got. One that's really interesting that's going on right now is folding at home. It's using protein folding. There's one that's actually started up for COVID-19, trying to map the proteins and the COVID-19 molecules. So if you want to know more about that, basically what you're doing is giving your computer's like processing time to somebody else. And so you would download like this BOINC, you know, a thing from BOINC, the Berkeley Open Infrastructure for Network Computing app. And then you can either choose a thing that you want to give your computer time to. Like maybe you want to find the next digit of pi or the next prime number, which is all the way up in the, I mean, it's insane how big prime numbers are now. Or maybe you want to say, I want to give to all the math projects, or I want to give to all the biology projects. So give my, you know, computer's time to that. So you could totally do that. You yourself are not doing the thing, which is why it's kind of like a subfield, or maybe kind of almost not even citizen science, but you are a citizen and your computer is doing the thing. So that could be something that you could work with. But there are so many different options. And then of course there's also, you know, just getting involved in your, you know, at your local museum or something. Maybe they have little projects like this. And so they're not even in you know, on the web in one big conglomeration thing. Maybe they're just, you know, in their own museum. So you can try that out. It should be pretty fun. So remember, I talked about a bunch of different ways that you could talk about citizen science, and how you can now see that it's, you know, crowdsourced science or volunteer monitoring. So everybody's trying to, you know, has a specific goal. So also think about, remember, here's the levels of involvement. And so now that we have discussed various things, now that you've seen several examples, what's the highest level of activity that you think you'd like to do? So go ahead and vote on this. And yeah, so everybody should be able to be in this, on a device. You can see the code up at the top. I'm kind of curious to see how many, if we added some people or not. And you might have been able to follow along on menti.com with the presentation that I had in there. So it's interesting, we've kind of gone a little bit more toward, I think, participatory science, where you are, remember that you can contribute to the problem definition or data collection. And remember, extreme citizen science, the addition to that is that you're actually analyzing the data along with other scientists. So, you know, in order to distribute it. So that's kind of what extreme goes for. So also, now that you have seen a bunch of these different things, I'm really interested in seeing which ones you're considering using. And so you should have a list on your device. And I put a whole bunch of, you know, them here. This is another one of those word clouds that you're going to put something into. And I know it takes a while to input 3 of them. Oh yeah, and by the way, it doesn't matter if you capitalize or not. All of them are lowercase. And so Zooniverse was the one that I showed you a little bit of. It's got like 100 projects, and so all sorts of different ones that are pretty exciting to look at. And AAVSO was the one where you can like actually look at stars and get your, you know, and see how bright they are compared to other things. So you're looking mostly at variable stars. So it looks like we've got, you know, about 25-ish people who've done it so far. It's awesome. And it looks like a lot of people are interested in distributed computing, which is pretty great. And, you know, that's just like unused cycles of your computer. You know, if your computer is just sitting there, it's, you know, that could be something that you could do. I'll just say that you should make sure if you're going to do this, you should make sure it's plugged in. All right. You know, if you're going to do distributed computing, make sure that it's plugged in. So it looks like we've got about 30 people. I think that's pretty awesome. Just took a picture of it. But anyways, I'm now really interested in questions that people have. You can put them into the chat in YouTube. And thank you very much.
Well, thank you so much, Erika. That was really informative. I have to say that I also use the Galaxy Zoo in my courses as well. And I've had a lot of students say that it's very addictive. And I have to agree, because once you get through one, then you see one that kind of sparks your interest, and you're like, well, what if the next one is like the one that changes everything nobody's ever seen before? So yeah, it is a lot of fun to do, and it's so simple to do too.
Yeah, they have a new version now, which is the Galaxy Zoo Mobile, and it's kind of like Tinder. You swipe left, swipe right. And so yeah, it's even more optimized for a phone.
We had a question early on. This was when you were talking about AAVSO data, but someone had asked, how are you helping astronomers by supplying this data? So I know that you had said in your own dissertation you use that data.
Yeah, and so the thing is that certain stars are, you know, are variable. They have different brightnesses, or they change brightnesses over time. And so sometimes it's really punctuated, like the one that I showed you, the R. Ophiuchi. And sometimes they just kind of like go up and down in their brightness, and we're trying to look at the cadence of that. And the thing is that when I did my dissertation, for instance, let's talk about my dissertation. I only was taking data for about 3 years for my own dissertation. But people have been observing that star since 1911. And so I was able to get information from, you know, basically, you know, 80 more years of brightness variance. And so then I could look and see if there were any like explosive episodes, or if it was just kind of like a, you know, goes up and down, or something like that. So professional astronomers do download that data and then look. And that was one of the things that happened with the Betelgeuse as well, is that it people downloaded data that had been taken for, you know, almost a century, and then looked to see that Betelgeuse was really getting a lot dimmer. I mean, it really got a lot dimmer. It got obviously dimmer, even to the unaided eye, which was kind of wild. So, yeah.
Yeah, I remember that. Yeah, and I'll say that in my dissertation, I also used AAVSO data, because I was working with some variable stars, and the data that I originally had, it looked like there might be a variation. And so sure enough, I looked up that star in AAVSO, and yeah, it was part of a much bigger oscillation that I hadn't seen before. So learned something there just from that data. Let me see, we've got a few other questions. What are the different physics projects in Zooniverse? Do you know?
Ooh, yeah, so I actually have Zooniverse open right now, so you can check it out yourself too. But in physics, There's 14 projects, and so some of them are like astrophysics, so like astronomical ones. But you've also got like an earthquake detective one, and one I kind of like is steel pan vibrations, where they kind of like put sand on you know, those steel pans from like Jamaican music.
Oh yeah,
Yeah, and looking at the harmonics of different steel pans. And so you can like do stuff with that. So it's pretty interesting. But for the most part, those are the physics ones are like astrophysics.
Okay, but they would be good for like, let's say, a 7th grade level.
Yes.
Awesome. Let me see.
Gravity Spy that has to do with gravitational waves, which are totally a physics thing, but because they come from astrophysical objects, then you can also consider them to be astrophysics ones.
Gotcha. And let's see here. Did you have any particularly favorite projects of your own?
Well, I've done AAVSO, of course, is, you know, close to my heart because I've used a bunch of their data, and I have contributed some data. I will say that to them. I usually do when I do AAVSO, I do unaided eye observing, just because that's kind of fun for me. I don't want to drag out my telescope or binoculars, but well, binoculars I do that, but still. So yeah, that's one of my favorites, just because it's like really interesting. But I do love various Zooniverse projects. One of my favorites is one that's already finished. So many people decided to, you know, do data analysis with it, or, you know, do the distributed intelligence with it. They classified all of the different things, and this was the Milky Way project, where people had to define bubbles within the interstellar medium of the Milky Way, which was pretty awesome. And then I will say that I am really interested in doing things like my toddler has started to be very interested in birds. And so I think we might eBird.
Nice.
He loves cardinals.
Who doesn't, right?
Yeah, right?
All right. I don't see any other additional questions. But again, thank you so much for the presentation tonight. Like I said, it was incredibly informative. There are lots of great opportunities out there. And so I hope that everybody that's watching tonight is going to jump on it and continue being a community scientist, or if they haven't done it before, they're going to start. So thank you again. And I also want to recognize Alex Rockefeller, who's works with me with Dyer. She's behind the scenes monitoring questions tonight, and also Brian Smokler, who's with VU Communications. He was making sure everything was getting out to the world for us tonight. So thank you all very much, and thank you again, Dr. Grundstrom. It's always a pleasure.
Welcome, and thank you, everyone. I hope that you go out there and do some science.
Definitely. All right. Well, thanks everybody for joining us, and hope you have a great night. Don't forget about our star party, our virtual star party, this coming Saturday. So please tune in for that. All right. Thank you all much. Bye-bye.